Welcome to our explainer. We're going to talk about a pretty fascinating idea today. What if a small, simple-looking block could actually change the fundamental properties of water? Sounds a little out there, I know, but a recent study decided to put it to the test.
So, an independent study took a device called the Leela Quantum Bloc and set out to answer that exact question. The whole idea was to see if it could measurably change a really key characteristic of plain old rainwater. Basically, its natural ability to clean itself.
All right, let's get right into it. We're looking at an evaluation that was done in Germany to see if the claims about this device could actually be measured scientifically. Now look, whenever you hear the word quantum attached to a product, it can definitely make you raise an eyebrow. And just to be clear, this study isn't trying to explain how it works, it's only looking at if a measurable change happens. So we're just going to focus on what the data tells us. So here are the quick facts. The study was carried out by a chemist, Oliver Kastner, over a few months, and he used something super basic: rainwater scooped out of a garden barrel. His whole goal was to measure one very specific and very important parameter of water quality before he used the block and then again after. Okay, so to really get what this experiment is all about, we have to understand the main thing they were measuring. And that's something called redox potential. So the official definition is, a little bit dense. Redox potential, or ORP for short, is basically a measure of chemical reactivity. It's a standard thing that's used in water quality testing to see how ready and willing the water is to, get into chemical reactions. But there's a much easier way to think about it. Just imagine redox potential as the water's self-cleaning energy. It's like the amount of power it has available to go out and neutralize contaminants and break down stuff you don't want in there. So here's the bottom line. A lower ORP means the water is pretty passive, less reactive. A higher ORP, though, that suggests it has a much greater ability to fight off things like pathogenic microorganisms. It has more, let's call it, disinfection potential. All right, so now we know what they were looking for. Let's dig into the actual method the chemist used. It was pretty simple, but also very precise.
The whole procedure was a really straightforward before and after test. Step 1, take a sample of rainwater and measure it to get your starting number, your baseline. Step 2, take that exact same water and expose it to the quantum block. And step 3, measure it again. That's it. But, and this is important, he repeated this whole thing 10 separate times on different days just to make sure the results weren't some kind of a fluke.
So, the big question. After doing 10 separate tests over several months, what did the data actually show? Did this block do anything at all?
Let's start with the before. The study found that on average, the untreated rainwater had a baseline reading of 168 millivolts. That was the average starting point for all 10 tests. And now, the after. Once the water was exposed to the Leela Quantum Bloc, that average jumped, and jumped by quite a bit, all the way up to 211 millivolts. This chart gives you a really clear picture of what happened. You can just see that obvious difference between the average starting point and the average ending point. And what's really wild is that every single one of the 10 tests showed an increase. Not one went down.
So if you do the math, that jump from 168 to 211 millivolts comes out to an average increase of 25% in the water's redox potential. But, averages can sometimes hide the really interesting details. Okay, now this is where it gets really cool. When you look at each test one by one, you see the changes were all over the place. I mean, sure, the average was 25%, but some tests only showed a tiny increase, like 2 or 6%. But others, they showed a massive, dramatic change. Let's just focus on that one outlier for a second. Measurement number 7. It started with a pretty low baseline, 150 millivolts. After exposure, it shot all the way up to 252. That is a 68% increase. By far the biggest jump in the whole study. And you can see how a result like that would really pull the overall average up. And check this out, you can actually see the raw data from the study right here. On the left, that's the graph for measurement number 7's baseline reading. You can see it's nice and steady right around 150. Then on the right, that's the graph after exposure, and you can see that powerful climb all the way up to 252. So, okay, numbers went up, what's the big deal? What does this actually mean in the real world, at least according to the guy who ran the study?
The chemist's conclusion was pretty direct. He basically said the data suggests the device has a positive influence on the water, and it seems to boost its overall reactivity by increasing its oxidative properties.
And that brings us right back to where we started. Remember how we said that a higher ORP, a higher redox potential, is linked to a better potential for disinfection? Well, the findings in this study point directly to that, suggesting the treated water has a stronger ability to purify itself.
So this leaves us with a final, pretty provocative thought. Now, let's be real, this is just one study with a small sample size, but it does raise some really interesting questions. If a basic physical property of water can be changed this much, what other kinds of applications or effects might be out there waiting to be explored? And you have to wonder, what other substances could be affected in a similar way?